This is packet number 6. So it's integration. Packet number 6. And we're dealing with problem number 1. Okay, we are looking at the accumulation function. The accumulation function is also known as the fundamental theorem of calculus, and it is one of the most important theorems in calculus. Now what it's saying is that if I have a function, and it's a t function, it's a function of t, so right here, this is y equals f of t, and this x right here indicates that I am going up to some arbitrary value, and I'm trying to add I'm trying to find the area under the curve from 1 to some arbitrary number under the f of t curve. So if I'm going from 1 to x, the first part A asks us, well, what's the function at 1? That means we're adding up the curve from the integral from 1 up to 1. So don't forget, integrals go from our lower or leftmost boundary. Okay, and this, the higher limit, okay, is our right boundary. That can be switched around, and we will get to that idea when we get to problem part F on this problem. So when we have, if we're going to take and we're going to find the area from 1 to 1, well, there's no delta x, there's no width in here. So the area, if delta x is 0, 0 times any number would be 0. So the area under the curve between some number, when the limits are the same, it's always going to be 0. Now, a of 4 means I am taking the integral from 1 to 4 of my function of t, dt. So I'm going to add up everything between 1 and 4. Well, if you look at it, from 1 to 4 is this rectangle in here. I have a distance of 3 and a height of 3, so 3 times 3 is 9. I have gone ahead and I have added up all those numbers for you and given you different values along the curve. I've also created and entered the different values in the problems from A to F. Now, 2 things to keep in mind. It's pretty straightforward until you get up to the value at 13. All the area is above the curve, so all the area is positive. When you get to 19 here, the value at 19, well, you need to remember that area underneath the curve has to be considered negative, okay? So the area is starting to decrease. So we have 2 spots where we're going to have to subtract off some area. The other thing to take note of is on the last problem, on the last question, F, I've written it as -3. So the area in here is -3, and the reason for that is our function started at 1, but now we're asked to go to 0. It's a t in here. Doesn't look like a t, so I'm going to take a moment to get that looking a little better. Okay. Our number on our base, our lower limit is supposed to be the lowest number. And, and, the, and we're supposed to go from left to right. Here we're asked to add up the rectangles from right to left. So this is equivalent to negative the area from 0 to 1. If you switch the limits, you just have to switch the sign on the integral. Okay? You can think about that as why that happens. Delta, we are moving from 1 back to 0, which means I'm going in a negative, my delta x is actually negative 1. So my base times my height of 3 would lead to negative 3. Okay, I've done a lot of writing on the last part of the problem for part G. It asks us to make a rough sketch of a of x. Now notice, it is a of x, all right? This function that I just drew has x as your horizontal, and it has a of x as your vertical axis. Okay, it is not a function of t. We have gone and looked down below here. We've added up to some x values. We have a of x. So that change will become a little more clear as the problems go on, but it is important to understand that you are working on an x horizontal and a of x vertical. Okay, so we, in a through f, I calculated a number of different values, and so I put those onto the curve, but I also did some color coding onto the original graph that you were given. Okay, over here I put a quick sketch of it, and then it's important to try to link the kind of curvature or concavity that you're going to have when you're working with these problems. So the first part, between 1 and 4, the values of the area, well, they're adding up at a constant rate. A constant rate leads to a linear function, so between 1 and 4, it's going to be a straight line. Now we started our values at 1, but we're also shown on the curve that we went back to 0, okay? And we talked about that being a value of negative 3. Well, where that leads to is that our function at 0 is negative 3. So you should include that on your graph. And the next part, the green part that I've highlighted, goes from 4 up to 7, okay? It's being 7 at the top of the peak here. That function's accumulation is accumulating at an increasing rate, and that leads to a curvature change. Instead of being a linear function, we now have a function that's concave up. And when you have the blue part, the area under the curve is accumulating in a positive sense all the way up to 13. It keeps getting higher and higher. Now, between 7 and 13, it's accumulating at a decreasing rate, and so that leads to the function being concave down. Likewise, I've shown the concavity changes on and color-coded them for the last part, so I think that hopefully that's enough to help you out.